Hello everyone, George here. If you don't know me, I am the Associate Director for Virtual Reality at Rowan University under Maverick, the Machine and Artificial Intelligence Virtual Reality Center. Yes, that is a mouthful. But in my spare time, I make YouTube videos like this one. And we have a special one today. I had a request, and what I've done here is open up the old Five Nights at Freddy's project. What was requested of me is to extend the existing code so that when the animatronics try to come into the room, and if you have successfully closed the door, they should no longer be able to enter into the room. Now I'm going to be opening this project up from where I last left off, and most likely because of moving between different versions of Unity and some other things that I had changed, some of this code is broken. I'm not going to hide that from you and try to get it back to a pristine state. We're going to look at this together, and hopefully as we do that, we can kind of unroll what the issue is and then also implement this new functionality. This scene was called A Night at Georgie's _01, and the system that we had before, I had an AI manager, as you can see here in the hierarchy right there, and this AI manager was programmed so that we could visualize the different pathways that animatronics could take from one location to the other. And at the time, we had things instantaneously teleporting, so what we're going to do here is fix this system. If we go ahead and hit the run button, we're going to run into an issue where nothing is actually functioning properly. Now, if we go down to the console, we're going to see that we have a null reference exception error. If we go ahead and double click this, it'll open up the script where this null reference happened. Usually when we have a null reference error inside of Unity, our go-to solution is to check the inspector and try to fix it there. If we come on down here, so this is a Visual Studio, we're going to go ahead and take a quick peek at this area. It says that an object reference not set to an instance of an object, and when we double click that, it's taking us to line number 22 over here in our script. Let's try to make this a little bit larger so everyone can see. So under here, we have a public bool called game over. It's got a getter and a setter. Now over here on our setter, we go ahead and set the value to be whatever you've passed in, and then we run this little bit of code here called loss.screentalks.gameObject.setActive value. So it is trying to do something to this value here, and it does not have access to it, which means that someone is probably trying to access game over and set it. The question then becomes, where is this actually occurring? So if we scroll down here, we'll see that null reference exception. Here we have play manager CS line, the play manager.cs script line 22. However, the real culprit here is play manager.start under line 68. So let's go ahead and click on that, and it'll take us to line 68. We have game over equals false. And because we do not have a reference to this object, which is a win or a loss object, a script itself, we are bailing out right there and nothing's working. So why don't we jump back over here real quick and get an idea of what the heck win and loss is. This is going to unite a text mesh object, which is going to probably be something like you win on the screen or you lose for the lose scenario. And it's going to have screen text here, and it's going to say you survived. Why I did not just use a single class that would do all of this functionality and just connect to that, I don't know. But it looks like we have access. We have a getter to the screen text object, which returns it, and we have a start and an update, and then we simply have a function called has1. Now this makes me wonder what the heck loss does. There's also a has1. So we have two scripts, same functionality, different class name. Yeah, this could have been handled better. So going back over here, the easiest way for us to fix this is just to check to see whether or not we even have the object. If loss does not equal null, we are going to go ahead and process this command right here. All right, so we're going to save that right there, tab that over as well. Now let's see if we can get past this null issue. Now we might want to give ourselves some hints. Debug dot, maybe a warning in this case, and I just want to say no loss object has been set. Loss script, how about that? Control S to save, coming back over here. I'm going to hit clear to see what happens. Save, run again. And now we have references missing for win or loss. We expected that. That's why we programmed it to do that. The next one we're going to be getting is null reference exception, object reference not set to an instance of an object. Now this is on line 80 of the play manager under start. Once again, we are trying to access things that are null because we never set them up. For now, all we're going to do is if win does not equal null, then we are going to go ahead and make this work. So enter over, tab that over, and then I am going to do the same thing again. I'm going to give myself a warning that just says we do not have this thing set. So let's do here, debug.log warning, no win script has been set because we're still in the setup of everything. I'm going to go and check an update. And what you'll notice is, and I believe I did this in one of the more recent videos, this was functionality that I had to remove. You'll notice the AI manager is there and it has the transitioning element where it's going to move the animatronics from one location to the next. This is something we're going to we have to go back to fix later on. I'm going to turn off, run, hit clear again. Once again, we're going to get our error missing, reference missing for win or loss. That's fine. We're still in this game over aspect, but what I really want to do is go over to the scene and start to get an idea of what's playing out. We've got our animatronics over here, but we probably have no system right now to make these objects move from location to location. So I need to go in and figure out why that's not working. So here's our AI manager. So here we have a series of nodes. Each one of those nodes over here is one of these objects you see there, and there. Let's actually turn this off and look through the scene view really quick and fly up. I'm using WASD on the keyboard to do that. We had set up a custom inspector object that allowed us to visualize the linkages between all of these objects. But you'll notice there's also animatronics, and then all of them are set to none. So when we hit play right now, all of the animatronics are going to be automatically loaded. So let's go into the AI manager, just coming back up to the top. Under here, we have awake. We're using a singleton to store this stuff. And then over here, we have transition occurred, which is the script that was being called in the play manager that we had deactivated. And under here, we iterate over every single animatronic, and then we do animatronics.whatever, and then transition. So we're going to need to take a look at the animatronic script as well to make this work. So we need to decide how we're going to handle stopping the animatronic from moving forward. So what we can do is at special nodes, we can define as you don't have the ability to progress forward. And we can query the door state and say, hey, if this door is not open, we cannot proceed further. That would be the simplest and easiest way to just move on from this problem. I'm going to grab the play manager and move it off to the side. So here under the update area, we have our deprecated code. And if not game over, the game over part is up here. When we do start, game over is set to false. So let's go ahead and start uncommenting out this code. So let's get rid of this here. I'm just going to move this over. And we're getting a lot of errors because we don't have access to these variables. Most likely I took these out at some point. So we have something called game time. We have a text.text, current transitions, transition times, all sorts of stuff. So here under start, we have transitions, transition times, floats, other transition information, and all of these also have been commented out. So let's bring them all back in right now. So under start, it looks like we need to set up all those different transition times. So we're going to go ahead and bring all that back in. So this is how many transitions are in this particular level. This is then creating an array equal to the size of the number of transitions you have. Then we have float delta. We have an end time and a start time, but no variables actually to work with. So we need to do something with that. Looks like I probably deleted those values. So we're going to need to create a new end time and start time value. Delta is the time between the start and the end. I don't know if that is accessed through a time manager perhaps, which is what I would probably have done. Right now, let's just put in some times. Start time is equal to 0.0f. Let's do end time is going to be equal to, let's say 120 seconds for right now. I assume it's in seconds. So we have a start time, end time. We need a type. We're going to do float for this one. We're going to do another float for this one as well. So end time minus start time. So we have 120 minus, it's really, that's a lot of seconds, isn't it? Let's go ahead and reduce this down to 20. 0 minus 20, 20 divided by the number of transitions. The transitions are between 4 to 8 plus 1, so we don't divide by 0. So we're going to iterate over every single potential transition that we have, and then we are going to take delta, which is the time for each of those transitions, and we're going to, it looks like, divvy them up, but also provide some sort of randomization. So yeah, it just looks like I was trying to randomize things. Interestingly enough, I'm not storing the times afterwards. I assume I'm going to iterate through every single transition time and then add them all up, and that becomes the total length of time of the level. Doesn't look like I did that, so that's probably an issue. Coming back down here, we have a value called game time. Game time, I assume, is the current amount of time that has been running in the game. Then we have this text field, which we don't have access to, and that is setting the clock on our UI as to what it is. Well, for right now, we're going to actually comment these out. So we have, no, that's not what I want to do. There we go. We'll comment out this, and then we will also comment out this line here. So if current transition is less than transition time dot length, times dot length, so it's the, if we have not completed all of our transitions because we're less than the number of transitions that are in it, and the game over and game time is greater than or equal to transition times that current transition time, then we are going to increment something that happens. We do not currently have a game time, and something tells me that I probably extracted that and put it on something else. So we have play manager, time passed, survive time manager. Let's take a look at this. So survive time manager, duration 5 minutes, hourly time, early time, time multiplier, actual time. This is what we want. We want access to the survive time manager class, this particular object. Now we also need to see whether or not this even exists within our scene right now. So survive time manager. Let's come on up here and type in survive time manager. Click on this right here and do it by type. I am not seeing that object. Let's see, let's find the game manager, and there's our play manager. Let's add the survive time manager to that. You can see as soon as I added that to it, the field values are updating. Let's go ahead and hit run. Survive time manager should start ticking down, except for the fact that we have a crap ton of errors. We're going to deactivate this real quick, clear out the errors. Okay, so we do have some issues going on here. Let's go to play manager, and under play manager, it looks like I got a little, I put too many of those in there. Oh, we still have issues with that time crap going on, right? I'm just going to, for right now, delete this. Delete this immediately. I'm going to put the date today. And what I want to do is do a float, and then game time is equal to 0.5f, something like that. I just want a value in there to move on. Now there's a level duration value. So if we go over to survive time manager, there is a duration value. So really, we need to get this class. We need to get access to this damn thing. How did we implement this? And so let's go up to the top under play manager, and I'm going to get access to this survive time manager. So we're going to go ahead and expose this. So let's do a serialized field. And then we're going to come down here and do a survive time manager, survive time manager. Okay, let's start using the survive time manager a little bit. What do you say? In Survive Time Manager, what do we have to work with? So we can do a serialized field. By default, these are going to be private, so I can't access them, but we can get a duration, but all of these are locked off. We do have a time finished value we can query. This area, let's see, play manager. Let's come in here and make an association. We're going to do this manually for now. So let's go over to game manager. And let's click and drag the game object into that opening. And I do not see it. Which manager are we? We're in play manager. So coming back up to the top, we have a serialized field, survive time manager. Unless this is giving us errors, it is. We have this level duration. So once again, we're going to come down here. And for now, just to get things to work for us, we're going to make that variable temporarily. So we'll do level duration here. And we're going to say the level duration is 1.0f, just 1 second. Let's go back over here. I'm going to clear this out and hit run. And there we go. So at least it's running, and we can see the actual time is updating, and our game time is also updating right there. So turning that off, now we should be able to access that. So we have under play manager, survive time manager, and everywhere we were using these different values. So we have the end time and the start time, these ones right here. We need to query these values and place them inside. So going under survive time manager, we need to be able to get what? We need actual time, game time. I didn't put a comment here to explain what the hell this actually is, so that's kind of an issue. Game time might be time in minutes, so that I can use this. So let's possibly the time that has passed converted to minutes. So let's make it so we can access a few different values. So what do we want? There's a start time and an end time. So let's just have the animatronics move from one sequence to another sequence as we progress through the level. So under update here, we have, so long as it's not a game over value, we're going to do this, which we're ignoring. And let's just do an IEnumerable for now and make something happen. So let's do a IEnumerator, progress animatronics, and this is just going to have a default value. So we'll do float, and we'll have this happen every, say, 5-ish seconds. So float delay is going to be equal to 5.0f. Here we're going to do a return, a yield return new, wait 4 seconds, and we're going to do delay as the time for that. Problems is equal to. And the next thing we need to do is the play manager is going to need access to the animatronics. So I believe this is a singleton object that I'll be working with. So coming over here, let's see if we can access it. So I'm not seeing a singleton anything over here. No instance value that I see either. So I'm going to need a reference to this object. Let's come back up to the top, and I'm trying to see if I had access to that in the play manager. So in the play manager, we have the survive time manager, and then we have the singleton instance right here, but I do not see a reference to the AI managing section of this entire thing. The question is, how the hell did we accomplish that? So we have AI manager over here, and the transitions occurred function is the one that we want to mess with. So we need to find all references of this function and how we can use that. So let's go to find all references. And in this case, we have AI manager.instance.transition occurred. We're going to yield return new wait for time seconds there. We're going to do AI manager.instance.wait for this to happen. We need to do this forever. So let's just do a while true statement. Do a while true, and do this and this here, and this should continue to fire until we're done. We'll go ahead and save that and click run. But all I really want to do is go over to the scene and see if we change the state of the animatronics themselves. Well, of course it's not going to work. We're not calling IEnumerator progress animatronics. So let's go ahead and call this at start. So once again, we're going to just put this up here, and this is a remove me for testing. We're going to do start coroutine, and we're just going to pop this right here, right there. Progress animatronic cannot convert method group to string. Call that right there. Okay, so now that we have that functioning, coming back over to the scene view, just going to see if anything happens. So they instantly jumped from one state to the next. So as you can see, they're moving down the hallway towards their final objective. And here they are at the room. Let's kind of ignore the fact that the head was removed from that object. So they're in the room. In order to move forward, we need to create a state where the room's doors are closed automatically and the animatronics are not allowed past that area. So let's go on over here, and under animatronics, at the moment, they're just moving from state to state to state, and there's no logic being run between each of these states. Let's come back here and go to each of the nodes and select them. And okay, so each of these is a node, and we have the node object right here. This node object has a connection out to all of the other nodes as well. So that's how we set up our hierarchy of movement from one location to another. We have an end goal. So security room itself has no outgoing nodes, and that's finished. I do not like how I programmed this. So a few things have to happen. We need to go to the door now and understand what's happening with the door to move forward. Now the door is part of a very densely nested object inside of the security room game object. So we have the light switch L, and then we have the bottom, we have the top, and then we have usable security door button script. Let's double click that. And it looks like we have what? So if we open that script back up, so we have usable security door button. So this is the value that we're going to need to query to decide what's going on. We are going to go ahead and do a serialized field on these so I can see what's going on. We're going to do that specifically on the door open value instead. So door open is equal to false. We're going to be able to see that. And what I want to do is toggle that value as soon as the game starts, turn that door to be closed. And then hopefully if we set up the rest of the stuff right, the animatronics will not be able to progress past that point. All the AI manager is doing is it's not handling movement is what it seems like. Instead, it simply tells the animatronic, hey, you have transitioned. Right now inside of transition is where we seem to be deciding where to go. All we need to do to make this work is we need to go back to the door, and we need to link the door to this and make that work. So this will be the fast and dirty solution. So let's come back to the game. I'm going to clear this out, and the door object itself, which has a door top, and it has this usable security button door. We need to go to close door and open door. And we then need to set that value, that node data value, to be a yay or a nay. Node needs to know about animatronic node data. There's a left and a right door, so we're going to have that functionality too. So let's do a serialized field, serialized field. I don't think I do anything to differentiate the two. I think the usable door has access to a door object, and then it's separately set up for each one. So we're going to have like a left door and a right door. So let's do usable security door button, left door, usable security button, right door. Grab both of these, paste that, we'll do right door. Now that we have access to both of these, we can query the state. Right now, this is a serializable field, but we do not have access to door open. Public bool get is door open, and in which case we're going to do a return door open value. All right, so we're going to come back over here. There is a if current location.name is equal to game over location.name. We need to see if the location you're moving into is the right one. We need to do a test here. So if current location.name is equal to, what we want to do is grab from, I assume, the valid nodes, travel to index.name. We're going to check this. Oh no, we're going to check it right here. If the valid node that we have decided on, its node is equal to the game over dot node, and this is giving me an error. Let's find out. Equality operator cannot be applied to type node and string. So this is game over dot name node dot name. We're going to say you are not allowed inside of this area. No, that's not true. Current location. So we will do this if this doesn't happen. If this occurs, we're just going to return for right now. The animatronic is going to get stuck at that location, or it'll just pause there actually, because technically one of the other outward pathways could always be selected randomly. So this would just cause it to just stay until finally it randomly queries an exit direction. We need to check the door state. So we want to grab, what was it, left door? But now I need to associate which door is the right one and what path am I currently on. So the entryway needs to, the direction that I enter into has to have an association with the left door or the right door. And that part, how do I want to do? That's the question. Yeah, there's nothing that links the actual hierarchy of the map to what's going on, which is kind of a problem. Screw it. Let's just do public bool is. So this is messy because we're breaking a lot of things. Right now, nodes have no concept of the left door or the right door. Public node, and we want to do node to left door, and public node to right door. I'm going to use the names of these, I think, to decide things, because the name is something that we're already working with in our code. If we use the fact that it's called door left and door right in the string value of the name, and under animatronic, when we're iterating over these different ones, we want to, so when we're iterating over the traveling part of this, right? So here we're saying if the next one we want to move to is the game over location, let's not do it that way. Let's do another check. Let's do checks to see if we are on the left or right side. We want to see if the node dot name is equal to, not game over dot location, but we're going to hard code this. We're going to hard code this as, what is it, door left. So the node's name was door left, right? I'm going to do door left. So if the next location, actually if our current location is door left, before we're allowed to do this, we're going to stop you. So we're going to do current location dot game object, current location dot name. Current location dot name is equal to door left. We're going to do the same thing over here for the other direction, door right. Current location dot door right. We're going to get rid of this really fast. We're going to check to see what the state is. So if we're at that location, we're going to query the left or the right door. So we're going to do left door here. So we'll do left dot door dot is door open. Okay. If left dot door is not open, it's not open, we're not letting you through. And we're just going to bail out of what the code we have now. So we'll do if right door dot is open is not open, then just return. We're going to bail out of all the code that would have made us move to the next position at this point and see how much we broke in the last few minutes. So I'm going to hit run. Actually, before we hit run, let's do a sanity check. Debug.log, and then we're going to say at the left door, and then at the right door, just to make sure we actually execute at the right door. And then inside of here, we're going to say debug.log, I'm not allowed in the left door. And then we'll do a debug.log, I'm not allowed in the right door. Come back over here and we'll run it. There we go. Go back to the scene view. We can see the animatronics moving from location to location as we were expecting. And what we hope is that they're not allowed in there. We have a null reference exception, but this did work. But we get this error right here, transitions going on, and find out what's happening. So in Play Manager, line 113, something's happening. So that's where we do the transition occurred segment of things. And I think what's happening is we're just exiting out and we're not setting we're not setting up stuff. So coming back over here to animatronic, we do if. We have to test to see whether the door's open or not, don't we? So why don't we add them? So we need references to those objects, right? So let's go over to the animatronics and let's see. So there's nothing there. Where is this? So left door is usable security door button serialized field. This is under the animatronic object, but we don't have access to this because we've completely rewritten the UI interface for this damn thing. So we need that animatronic editor thing. We're going to take a quick look at this. Let's add these after this right here. Okay. We just have no data and we're just using the name. We don't have a reference to the actual object. So we're probably going to have to do this. Although if we had the node object, the node is not on the door. No, we still need a reference to the door. Now, the only other thing I can think of is, did we set up tags for the different doors? I'm just trying to think about the easiest way we can do this. So the door element itself is untagged as well, so we can't use that. Usable security button, we could query it, but we wouldn't know which one is the left or the right object. We'd have to check the name of the object and see if it was left or right. So here we need to specify animatronic script.start location. So animatronic script. So we want to do animatronic script dot, and then we want to do left door. So let's grab that and paste that in there. It's going to be equal to, we're going to kind of copy this stuff that's going over here. And it's been a while since I've done editor stuff, so I do not know exactly what the hell I'm doing. I know that we need to convert this over to the type, which is going to be, what is this? This is usable security door button, which it doesn't remember. So coming over here, we need to grab this name, and I'm going to type it wrong, so let's get it right. So we need to typecast this over to usable security door button. Let's call this left door button, and animatronic script.start location, type of node, type of should be usable security right there. Animatronic script.start location. I'm not exactly sure what that is. Object type parameters. So this should be animatronic.door left. It's the same variable. This is the previous value of that. I think it's whatever it's replacing. So we're going to copy this, paste this here. We're going to do right door button, and we're going to change this to right door, and then that's going to be usable security button true. We're going to switch this to be right door right there as well. Save that. Come back over here. The editor is going to explode. Animatronic does not contain a definition for left door, and no extension method left door is accepting the first argument. Animatronic script.left door. Animatronic script over here is private. We do not have access to it. So let's change this to public for the moment. So we're going to copy that and paste this here. We're not going to deal with that. So coming back in here, saving this, going over here, the errors disappear. Now, if we take a look at the animatronics themselves, we should be able to associate them with that game object and move on. We're going to lock down that selection really fast. And we are going to go to the door object, and we're going to set the left one. So coming over here, we're going to go to the light switch, and it looks like it's the top, right? And put that to the left one. And then we're going to go to door switch right, and we're going to go to top and put that one there. and then we're going to do this for the remainder of the animatronic objects. So we got to do this for every single one, which kind of sucks. So we're going to go over here to the other one, lock that down, come back over here, grab our top value, grab our other top value, put that there, unselect it, come back over here, select this, lock that down. We're going to come over to the top value and the other top value as well, unselect that, and go to Foxy and select that one, and let's do top and top, save, and we're going to hit run. And in a perfect world, this will just work. So coming over to the scene view, so we have this one moving down. So this one's now at the door, and we're waiting for that output. And if we're correct, yes, at the left door, but the door was open, so they would be able to progress through that door and kill us, right? So we're never going to get that other state fire. So we're going to stop this for a second. What I want to do is hit play again. I'm going to close these doors off so that that other code functions. If that other code functions, you can then stick whatever you want inside and make it work. We do not currently have, access to the to that variable, do we? So what I'm going to do is, just to show you that it works, is we are going to go under the usable security door button, and we're going to set the state of this thing to be false. We're going to have them closed. Closed door section. So start, we have door open is equal to true. Let's just use the closed door function. Power outage, we're going to call start coroutine closed door. So what we want to do, we're going to do that right at the beginning of the entire game for both of these. So I'll go ahead and hit run. Come back to the scene. Both doors, you'll notice, go ahead and close because we set them to close right at the start of the game. And so long as, I believe we've already removed things like the power management system and whatnot, that won't override it. It's not like we're sucking up all the power within the game itself. At left door, I am not allowed in left door. So there you go. That is how to stop your animatronics from getting inside of the room. Now that might have seemed like a lot of work to do something very simple, but we had to identify all of the problems associated with the scripts and how these things all worked. But pretty much you can now add any code you want to in that little area, and it will execute when the animatronic gets to that location. And you can extend that to pretty much anything else that you want.